In this screencast, we're going to explore the CalculatorValue class. This class is inside of the inexact unit calculator package, inside of the calculator baseline with double values. So let's take a look at the class. This is the class declaration, and as we see, it doesn't extend anything. It starts with a number of constant declarations. These are some character declarations to give us the ability to deal with superscripts of 1, 2, 3, 4, 5, and 6, a superscript minus, and a dot operator. We need those for this array. This is the array of units that the calculator value class supports. Calculator values consists of three things: a value, an amount of uncertainty, and a representation of the units that this value uses. So for instance, if we have 15 meters and 27.5 kilograms, those are examples of the value and the units. And so we represent units by an index code, and this is the table of index codes. So the default unit is a unit with the value 0, which is no unit at all. And then 1 is millimeters, 2 is centimeters, and so on and so forth. We see here is millimeters to the 4th power, and here is millimeters followed by a dot operator followed by grams. So this is an example of the result of what happens if I take a millimeters object or value and multiply it by a grams value. We're allowed to multiply things of different units, but we're not allowed to add or subtract things if the units are not exactly the same. So we have this very long table of units that represent the cross product of all of the different units that we support as input values in our calculator. And they come all the way down here to support all the way down to number 494. Then we have these tables. This is a table that supports addition. And so this table is organized as a two-dimensional array. And if we add or subtract operands with no units, then that would be in this row and this column. And so we see the result of adding or subtracting values with no units. The result has no units. Here, if a value is entry number 1, which is millimeters, if you add millimeters to millimeters, you get millimeters. And if you subtract millimeters from millimeters, you get millimeters. The minus ones indicate an attempt to perform an addition or subtraction where the first operand and the second operand are not of the same type. And so if they're the same type, then that would give us this diagonal 0, 0, 1, 1, 2, 2, 3, 3. And so you can see working the way down the diagonal all 18 different kinds of units that the calculator supports generically. And then the product of 18 times 18 is the square. And in the case of addition and subtraction, these tables are the same, so we have just one table for them. When you do a multiplication, things get very different. And so what happens is that we support multiplication of certain kinds of values. So if we have no unit specified for the first operand and some units specified for the second operand, then we're able to perform or we use the result from the operand that does have units. In the case where both of them have units, then this table represents the relationship of when those units can be multiplied together, and if so, what the result is. And the value inside of the table, so this 29 right here, says go up to the first table to item 29, and it's this one right here. And so what we have is centimeters to the 4th power. So that's what 29 stands for. And you'll notice that in this table of multiplication, there are some minus ones. You're not allowed to multiply meters times millimeters, but you are allowed to multiply millimeters times grams or millimeters times kilograms, and so on and so forth. And so there are definitely places in this table where it is not valid to multiply two things. But as you can see, comparing this multiplication table to this addition and subtraction table, there are many more combinations that are valid in multiplication than there are for addition and subtraction. Here is the division table. And similarly, the division table is very much like the multiplication table, with one exception. Notice this diagonal of zeros. If I take a value of 1 unit and divide it by a value of the same units, I'm left with a ratio or a result which has no units. So if I take 15 millimeters and divide it by 3 millimeters, the result is 5 because the millimeters cancel out. And so the division table is represented here and the multiplication table there. Now we have the three private attributes that represent the calculator values. This is the actual value of the calculated value. This is the error term, or the amount of uncertainty. And this is an integer that represents the units. And so the integer is from that table above. So if we want to write something out, we can do that by using that index for this variable here, an index into that table at the top, into this table right here. And so if we look into result unit names and we use the index into this array, we will get the appropriate string for the units as a result. We also have a scientific formatter to convert the double value and the error term into human readable strings. We have a constant here for plus or minus for the uncertainty term. And that covers all of the attributes for this class. Now we have a set of constructors, and there's a fully parameterized constructor that defines each of the three fields: the value as a double, the error term as a double, and then an int for the units. And the sequence or the ordering of the units here agrees with the definition of units inside of the swing front end. And so for the first 18, they are exactly the same as they show up in that user interface. Here is another constructor, and this constructor is a copy constructor. So it creates a new calculator value based on the value of an existing calculator value. This is a default constructor value that initializes everything to 0. And then we have a couple getters, a set of getters, one for each of the three attributes. We have a toString method. And then we have a set of 4 operators. This is for addition, subtraction, multiplication, and division. So let's see how that works. We create a new calculator value based on adding the values, the value fields, the value attributes of the A and B input parameters. Then this is the computation of the error term based on information from the paper that you were provided in Java 1. And this is using the table where A units is the index for the first array or first row, which row, and this is which column. And those two indexes specify one of the values from the table, and that value is then used as the resulting units for the new value that is computed. In the case of subtraction, it's exactly the same, except now instead of a plus operator here, we have a minus operator. Notice that when we have error terms, the error terms grow even though a subtraction is performed. And so error terms, every time you do computation, you tend to lose significance. The third operator is multiplication. And this is a little different in the fact that the computation of the error term is a little more complicated than in the case of the addition and subtraction. This again was defined in the paper from the Java 1 class. To compute it, we compute the product here. Then we take the absolute value of that product and then use the absolute value of that product, this E, to come up with two ratios, and then we add the ratios together. And so this way, if one error term is significantly different than the other error term, the ratios are added together. Similarly, as above, we compute the resulting units based on the units of the two operands, where the first operand gives us an index into the number of rows, into which row, and the second operand provides us the index for the column. And once we have a row and a column number, then that will tell us the number of the units for the result. Division is very similar, same sort of a process. Remember, we've checked the division earlier inside of the user interface, so we know that B is not too close to 0. So therefore, we may simply go ahead and compute the quotient, and we follow the same approach of using these ratios to determine the size of the resulting uncertainty or error term. And again, the units for the result is computed by taking is determined by using the index from the units for the first operand as the row and the units for the second operand as the column, and then use the divide table to specify the units for the result. And so we use this fully parameterized constructor of new calculator value to produce the result, which we then return. And that covers the calculator value class for the calculator. I hope this coverage of the code proves to be of value to you.